Today we're going to look at the F765 wing and connecting a GPS. And the GPS we're going to use is this M8Q M8Q-CAN GPS. GPS, compass. Can't remember if it's got a barometer in it or not. I don't think so. One way to check real quick is to look at the chips on the bottom. Yeah, I think it has a barometer in it. If you look at this chip right here, oops, you can see there's a hole in it. That usually means that's where the air pressure gets in, and that's a barometer. We'll look at here in a second. We'll be able to tell in just a quick second. So first of all, let's look at the 765 wing and where we're going to attach this. And we've been working in this bottom right hand corner on an RC receiver. Well, if you look just above that, there's another serial port called UART2. And we also have voltage and ground to the right of that. And the next pair of pins up. Let's go over to the home page and look up flight controllers again, and we'll look up the 765 wing, and we'll go down to the layout. And here's what we're talking about here. We're talking about picking up ground here on this pin. Okay, let's go ahead and talk about this right now. This is the 4V5 voltage. I don't know why they named it that, but it's noted right here. The 4V5, this pin and this pin, I think that's all the pins that are associated with that voltage. And I'm not sure completely. I think it's just these two. That's 4.4 volts to 4.8 volts at 500 milliamps of current. And this is the important thing. The voltage is also supplied when connected via USB. That's why when you saw me plug in the USB to this port right here with the receiver connected last night, this voltage came up and the receiver turned on. No battery connected to the flight controller yet. So this port right here is also going to do exactly that same thing. When the USB is connected, it's going to power up 4.4 to 4.8 volts on, this pin right here. That'd be a great place to put our GPS, in my humble opinion. Ground, supply voltage. If we can run our GPS off of a UART, we've got a UART right here, UART2, sitting right there waiting on us. We look right here, there's also on UART2, a little further to the left, a DA and a CL. Right here, we hadn't talked about these 4 pins here yet, but here's a DA and a CL. That's an I2C bus. It's sort of synonymous like a UART using a transmit and receive. This uses a data line and a clock pulse. All the peripherals have an address. So if your address is up on the data line and a clock pulse comes along at the right time, you communicate. That's not exactly how an I2C bus works, but it's just showing you it's a little different from just straight transmit and receive on a UART. And all the DA lines are tied together, and all the CL lines are tied together in an I2C bus, because it's not a transmit and receive situation. Every peripheral on the bus hears everything that goes on, but it knows to only pay attention to transmissions addressed to it, because each peripheral gets an address on boot up. So this also says that on UART2, the DA and CL on the I2C bus are for compass. Wow. If I remember correctly, there's a compass inside that GPS. There frequently is inside GPSs. Saw a GPS yesterday. I'm going to talk about it right here, because I think I can find it right here. This is a GPS with a flight controller on the bottom of it. Basically a 405 wing on the bottom of it. F405 and M9N multi-constellation GPS. I2C bus, CAN protocols, UARTs. Anyway, I get distracted frequently, but I thought you might be interested in that. Back to this. So compasses frequently come on GPSs. Like I say, now they're even putting more on the GPS module. So UART2 seems to be set up here to hook up a GPS on this UART and a compass on this I2C bus. This board just seems to be well laid out, and the fact that the 4v5 voltage is present when the USB is connected to this flight controller through this USB port right here. You can go to the field, plug in your notebook computer USB port to this port on the flight controller, and go. That brings power up on this pin, and your GPS and compass come up at that moment. So does your RC receiver. In my case, Crossfire Nano, a transceiver. So it does come up transmitting, and it does come up creating more power than just a straight receiver would. But also, the GPS is powered up. It can start locking in on satellites, making calculations, settling down, getting as many satellites as it can, and getting a good lock on those satellites it finds before you've even connected your flight battery, your LiPo, to the flight controller. It's sort of like a rocket launch. It's an umbilical cord over with external power, and it brings up some of your peripherals. In my old days in the Navy, the INS and inertial navigation system was a gyroscope in the airplane that took like an hour or two or more. I don't remember. The AEs did it to align. I mean, it took a long time for that INS gyro to align. Nothing like the electronics we have today that aligns almost immediately. But that's somewhat what goes on with the GPS. It's coming up for an alignment on GPS satellites. So, I mean, if you're unpacking, if you can set your notebook, set up your table at your flying field, put your notebook on it, turn it on, put a USB cable over to your plane, plug it in, Then start unpacking the rest of your equipment and stuff. Your GPS can be going ahead and getting warmed up. Everything starts getting warmed up. The accelerometers and gyros in your flight controller get warmed up and stabilized. While it's sitting there, I am going to take advantage of this at the flying field. And when I talk about a different way a GPS hooks up, it won't be on this, and it doesn't have voltage from the USB, is why I'm mentioning this. But in this case, using this GPS we're using, it will power up from USB voltage along with your RC receiver. And I know that means your RC receiver's now powered up first, your radio's still in the back of the car, isn't even turned on, and that's not proper procedure. But I tell you the truth, I'm not going to turn my receiver, my whole platform, back off and disturb my GPS lock. It'll still come, when it comes back up, it will still lock up faster because it's in the same place it was the last time it was turned on, even if you do that. But I'm not going to shut down my receiver, causing my GPS not to have power. I'm going to go ahead and turn on my transmitter and make sure it's bound up, and then turn on my flight controller battery when it's time to do that in the launch sequence, and then unplug my USB cable such that I never lose power to my GPS. And so that's just my way of doing things. A lot of people may have trouble with that. I think it's time to go over and look at the GPS I've chosen. So we'll go back. It's another Maytech. I'm going to call it Maytech. I just like that better than Matech. I would love to hear the owners of the business tell me how to pronounce it. Again, a GPS with a flight control on the bottom of it. That is crazy. I have some of these GPSs. These are 4 Constellation M9N GPSs. We'll look at them too. I also have this digital airspeed sensor for us to look at. But what we're really after right here at this moment is this GPS right here, the M8Q-CAN. If we look back at the one here on the desk, that's what I have in my hand, the M8Q-CAN GPS module by Maytech. It's got a I2C port. It's got a UART port, UART1 and UART3. Interesting. UAV CAN protocol and UART MSP protocols. Okay. So if we go down through here, oh, did I see oh, it does have a barometer in it. This DSP310 right here is a barometer. You can see right here, it's got the compass in it. Okay, yeah, it's got the M8Q GPS in it, the QMC 5881L compass, DSP310 barometer in it, and then like I say, I2C bus and UART bus. Got a UART1 firmware update. UART2 onboard GPS. UART3 MSP protocol. CAN bus, I2C, compass and barometer, and I2C connector for an external airspeed sensor. We'll look at it here real quick. Again, that proves this chip with a hole in it is the barometer. There it is again. There it is. Put in a 743 wing with a CAN bus. Gee, now do you see why I ended up buying the 743 wing? I don't have a CAN bus on the 765 wing, so I couldn't plug into this center CAN bus on this GPS module. I actually have two of these. One I bought 6-8 months ago for the Caprihina 2, and one I bought recently for the 765 that was going to be a bench flight controller and GPS for learning all this stuff. And then it also, coincidentally, it shows a 4525 airspeed sensor connected to this port right here, which is a, looks like it's an I2C bus. Let's look at a better pinouts, wiring. Again, it shows a 743 wing going straight into the CAN bus. And again, we have our I2C going to the airspeed. Here's me. And it shows a 765 wing right here at the bottom. It shows ground, going to ground on this UART port over here. On this side of the GPS module, shows this voltage, supply voltage, going to this pin. Shows a transmit voltage coming out of the GPS on this pin, going over to the receive on UART 2 on a 765 wing. Shows a receive pin on the GPS module right here, listening to a transmit pin on UART 2 on the 765 wing. I don't have a CAN bus. This is the way you hook it up on the 765. So now, if we go back out, I'm going to pull just a little bit of a fast one on you. This is our M8Q-CAN GPS module, and this is the other one that I told you I had. I've got this in the shrink wrap and everything now, ready to go in the airplane, and I'm not wanting to talk about this. Ignore this wire. This wire does not exist. So there I am. I've got a connector connected on this side of the GPS. And if we, the shrink wrap kind of got that messed around. Now, this was one of my complaints too. We got the red wire on one end of that connector, black wire on the other, and then we have blue and what color? Blue and yellow in the center for transmit and receive. So I just Put that in a 4 connector pigtail I had. This was while I was prototyping and doing my experiments. I just soldered these wires together and put some shrink wrap around it. And what I have in this 4 conductor DuPont connector on this side is exactly what we have on UART2 on the screen right here. We have the ground supply voltage, the transmit signal coming over from the GPS UART port, and the receive signal coming over from the GPS. And this is oriented, if we turn it 180, there we are, exactly like the layout picture. Ground voltage, receive and transmit. This just goes right straight down to the board and plugs into that second line of pins on the 765 wing. And so now we have 4 wires plugged in. Oops. We have 4 wires plugged into the UART port on the right side of the M8Q-CAN GPS module, compass, barometer, dishwasher, lawnmower, whatever, module. And it's ready to go. That's really all there is to that as far as wiring it up. Now I'm setting that way away from everything. The GPS, you noticed, I just put it as far away. It's not even in the video anymore. We'll keep this GPS in the video for reference. There's another one plugged in up there. And now we do the same thing we did before as far as electrical and setting this up. And again, there's no battery plugged in out here yet for the flight controller. But if I plug in the USB, you'll see that I get a blue flashing light on the GPS module. I'm just going to move it that far away. I do get power to that GPS module. It is starting to lock on to satellites. It's doing its thing. So now we need to go back into INav. Oops. Here we are in INav. Let's connect to our flight controller. We'll go to the ports page. This is the standard out-of-the-box setup of a new flash of firmware 261. I do not know why UART1 is set in MSP mode. If anybody out there knows why, by all means, let me know. I'm going to just shut that down. I don't know if it's going to... No, I'm not actually. It must be set for some reason. Anyway, if we go out real quick, oops, I messed up. We need to go back and look at some more of the data on the GPS. For INav, excuse me, we're going to be using it on a UART. In the Ports tab, enable MSP on the corresponding UART that the M8Q-CAN is connected to. Do not enable GPS on that UART and select baud rate 115/200. GPS provider, MSP, magnetic hardware, that's the compass, magnetometer in truth. Set to MSP, barometer MSP, compass alignment, rotate clockwise 90 degrees if compass is mounted flat with arrow facing forward. And flight control arrow is facing forward also. Not sure that those have to be in conjunctions, but whatever. If MSP doesn't work, please update M8Q-CAN to latest firmware first. MSP sensor has not been implemented when the M8Q-CAN was first launched, and I ran into that. In honesty, I have one of these M8Q-CAN GPSs works for me, and the other one does not. And I didn't want to have to say anything to race day quads about that fact, because it's obvious to me that it's up to me to flash it with the current firmware before I do that. But then, because it also has CAN bus, I ordered a 743 wing, which has a CAN bus, and the older GPS does work with the CAN bus. And so both of them do work for me on two different flight controllers. So everybody's happy, don't have to say a word. So armed with that information, let's go back to INav. So we're on UART2. We plugged that into UART2 on the board, so it says to enable MSP and set a baud rate of 115/200, which is the default. We're through there. Looking up here at the top, we don't have anything with GPS. So we click in the bottom right now, save and reboot. And we reboot. There's our last change. That's not all we have to do. We have to come into configuration, armed with the other information we just talked about, and we have to come back. We have to come down here and turn on GPS for navigation and telemetry. Select the MSP protocol, which was already selected. I just selected a different one and then selected MSP again as an example. I do believe I can click GPS use Galileo satellites. I think this GPS sees two constellations, its main and then the Galileo constellation. Not sure of that. Don't think it would hurt leaving this in either direction. And I think my time zone offset is a -5 for where I live, New York, basically, in the United States. It says in minutes, so that's confusing to me. Don't quite have that exactly right yet. And automatic daylight savings time, not sure about that myself. So we also saw that the magnetometer is an MSP. The barometer is MSP. Now, was there something for the barometer, magnetometer, and GPS? Okay, and then the clockwise 90. And then down here, the magnetometer's alignment. I think this is for the main board, these three. And this is for the magnetometer or the compass, and you want to say clockwise 90. Anybody finds what I'm saying here is incorrect, please correct me. I'm not trying to put out any kind of false information. Okay, looks like use sensor alignments, gyro, accelerometer, magnetometer, to define sensor position independent from board orientation. So at that point, we click Save and Reboot. And it comes back up, and lo and behold, if we look up here at the top, we have a magnetometer that is in the blue, which is green. We have a GPS that says it's happy. If we look back at the table right now, let me get my bamboo skewer for a pointer. We can see, if we look at the GPS right here, we can see that not only does it have a blue flashing light for status, it has a green flashing light now that says it has satellites. And if we come back into INav, we go down to GPS and INav, you can see we have 7 satellites connected. We have a latitude and longitude. Might not be able to see it. We're communicating at 5 hertz with a GPS. Go back up here to setup, scroll down to the bottom. We have a 3D fix on the GPS, 7 satellites, and again, a latitude and a longitude. Technically, we're finished. Now there are other things to do. We haven't calibrated our compass yet. We haven't even calibrated the accelerometers on this flight controller board. We've just hooked up the RC receiver, and today we've hooked up the GPS. Technically, we're finished, but I'm going to show you one last thing here real quick. I'm going to hook the RC receiver back up to the flight controller. I'm going to
Welcome to OpenTX.
Go back into my radio. Yesterday when we did the RC receiver, you'll remember we went over into the model setup, went over to the telemetry area, and we discovered telemetry sensors. And we came up with 19 sensors that are being transmitted through the Crossfire Nano transceiver back to my radio in my hand, and also senses from the flight controller. We picked up 19 sensors doing that. I kept calling them 18 sensors yesterday when we were doing the RC receiver, but there were actually 19. Now with the GPS connected to the flight controller and set up in the software and working, if I click Discover New Sensors Today, click, we picked up, let me count them today, 1, 2, 3, 4, 5 new telemetry sensors. The bottom one says 5 sats, flipping between 5 and 6 right now. I have an altitude. I have a heading from the compass. I have a ground speed from the GPS. We have GPS coordinates there. And then we're back to the 19 from yesterday. So picked up 5 more telemetry measurements being either generated in the RC receiver, or generated in the flight controller, or generated in the GPS now, that are being relayed back to my radio, that if I was using Ardu Pilot would also be going Mavlink down into my ground station through Wi-Fi for flight telemetry. It just gets better and better, doesn't it? So there's connecting a M8, or what was it? A M8Q-CAN GPS from Maytech to a Maytech 765 wing flight controller, and setting it up in INav and getting it working. I have also here a Belton BN880 GPS that works on a different kind of bus we can look at later. I have a the M9N '5883 GPS with the multi-constellation that we'll look at later. I think there's one other kind of GPS around here someplace that we can look at how that hooks up. But anyway, that basically completes the how to hook up a GPS to the 765 wing and how to get it all working.